Have you ever wondered how a warm patch of water in the Pacific Ocean can trigger floods in Peru, wildfires in Australia, and even impact the fish you eat? It sounds like a plot out of a fantasy novel, but it's real. It's called the El Niño Southern Oscillation, or ENSO for short. And whether you realize it or not, this global climate cycle is already affecting your life. Hi, I'm Alex McColgan, and you're watching Astrum. Today, we'll uncover the science history and far-reaching consequences of El Niño and La Niña, two opposing forces that are reshaping the world's weather systems, often with devastating results. Life on Earth is built on rhythms. We have the daily swing of day and night, the annual march of the seasons, the endless pull of the tides. These cycles are reliable and easy to track. But zoom out further, and you'll discover longer, more complex climate cycles. Some take centuries, even millennia to complete. One such long-term cycle is the Milankovitch cycle, which plays a role in triggering ice ages. But for most of us, these changes are too gradual to experience in a single lifetime. There is one cycle, though, that we can't ignore. It's shorter, more volatile, and increasingly influential. El Niño and La Niña. Together they form the El Niño Southern Oscillation. And this cycle is becoming stronger, more frequent, and more destructive. The story begins centuries ago. In the 1600s, Peruvian fishermen noticed something strange. Around Christmas, the usually cold coastal waters would suddenly warm up. Fish would vanish. Catches would dwindle. They called it El Niño de la Navidad, the Christmas child. For a long time, no one connected this local phenomenon with similar disturbances happening on the other side of the world. It wasn't until the early 20th century that scientists started piecing the puzzle together. By the mid-1900s, they realized that these seemingly isolated weather events were part of a vast, interconnected system. Thus, the El Niño Southern Oscillation was officially recognized as a global climatic pattern. To understand how El Niño and La Niña disrupt the climate, we must first understand the normal state of the Pacific Ocean. Under typical conditions, trade winds strong. Persistent easterly winds blow across the equator from South America towards Southeast Asia. These winds push warm surface water westward, away from the coast of South America. As the warm water leaves cold, nutrient-rich water from the ocean depths, rises to replace it in a process known as upwelling. This upwelling fuels ecosystem supports thriving fisheries and maintains a stable climate balance. During El Niño, those trade winds weaken or even reverse. As a result, the warm water that normally travels to Asia begins to accumulate along the Pacific coast of the Americas. Without the trade winds pushing it away, the upwelling of cold water slows down or stops. The ocean surface warms dramatically. Nutrient levels drop. Fish migrate or die. Coral reefs bleach and perish. This isn't just a local problem. The Pacific jet stream shifts southward, altering weather patterns across the globe. The northern U.S. becomes warmer and drier. The Gulf Coast and coastal South America, especially Peru and Ecuador, see heavy rains and catastrophic floods. In the historic 1997 to 98 El Niño, Over 250,000 people were displaced in Peru alone as rainfall in tombs reached 16 times its annual average. Across the globe, droughts struck India and Australia, sparking bushfires and food shortages. If El Niño is the warm, chaotic phase, La Niña is its cold, intensified counterpart. During La Niña, the trade winds grow stronger, pushing even more warm water toward Asia and allowing even more cold water to upwell along the Americas. This supercharges marine productivity. Cold water species like salmon and squid spread further than usual, boosting fisheries. But it also leads to extreme weather shifts. In Asia, La Niña brings heavy rains and stronger tropical storms. In North America, the jet stream shifts northward, causing drought in the American Southwest and wetter conditions in the Pacific Northwest. In 2022, La Niña contributed to the worst megadrought in the southwestern United States in 200 years, drying up reservoirs like Lake Mead and exposing the so-called bathtub ring around the Hoover Dam. The effects of ENSO reach far and wide. In South America, El Niño floods Peru and Ecuador, while La Niña brings drought to Chile and colder weather overall. In Australia, El Niño dries out the bushland, often sparking deadly fires. In 2020, during a non-El Niño year, fires destroyed over 50 million acres. Imagine what a strong El Niño could do. In India, El Niño disrupts monsoon patterns leading to famine. La Niña brings more rain, but sometimes too much. In Africa, East Africa experiences drought during La Niña and floods during El Niño, while Southern Africa sees the opposite. In the Atlantic, La Niña increases the number and severity of hurricanes, whereas El Niño tends to calm the storm season. It's a planet-wide domino effect. Wherever you are, ENSO likely touches your climate. As of this recording, the NOAA has declared that the recent La Niña event, which lasted nearly a year and a half, has ended. The Equatorial Southern Oscillation Index, EQSOI, a key measurement of atmospheric pressure changes, has returned to neutral levels. But El Niño may be on the horizon. NOAA estimates a 60% chance it will arrive by autumn of 2023. India is already warning of drought conditions. And historically, we've never gone more than 4 years without an El Niño, since tracking began in the 1950s. If none happens this year, it would be the first 5-year gap ever. ENSO isn't just about predicting the weather. It offers insight into the complexity of Earth's climate systems, the push and pull between air, ocean, heat, and life. More importantly, it shows us how climate systems on one part of the globe affect others. This understanding could prove vital if we ever aim to terraform other planets or build self-sustaining environments in space. Mars, Venus, or even a distant exoplanet all would require intimate knowledge of cycles like ENSO to be habitable. So studying El Niño isn't just about survival on Earth. It's about the future of humanity. The El Niño Southern Oscillation is one of the most powerful and fascinating forces shaping our climate. From coral reefs to megadroughts, its impact is everywhere. What about you? Have you seen its effects in your corner of the world? Share your experience in the comments. And if you want to dive deeper into the science behind climate, thanks for watching. And as always, stay curious.